All right, we're back here with our Honors Stats class, period 2. We're excited to do our first ever scatter plot. Now, what we've done is we are taking the data values from this problem about horsepower and miles per gallon for these vehicles, and we are going to show that scatter plot after we plug it in. So what I want you to do is, you'll notice you're not seeing any points, so we need to go to the wrench. And we're going to type in our different x-axis for our lowest and highest numbers. If you look at horsepower, what's the lowest horsepower for the cars up here? 138. So let's put in 135. 135 for our lowest. And then for our highest, I've got a 306, this Lexus. So 310. All right. For our Y values, what's the lowest miles per gallon we're getting here? 18, so 15. And then what's the highest miles per gallon we're getting? 40, so that seems like a lot. Let's do 42. All right, now, if you want to see the full picture, you can hit these double arrows to hide this. We're going to bring it back, though. So there is our scatter plot. All right, here is our scatter plot. The moment I make a scatter plot, the moment I make it, we just did, I should be thinking direction, form, and strength. All right? So the statement that I would write would be, there is a, do you want to write this statement? Let's see if I can I type in this thing? Yes. Excellent. There is a, what, we are just changing the game. There is a, so what do you guys think for direction? What do you think for direction? It's going from top left to bottom right, so that'd be negative. Okay, so there is a negative, comma. What else do you think for form? Direction, form. So form would be like linear or not linear. So linear. Now here's the thing, Liam. If we don't say linear, we got to stop. So let's keep it linear. Okay, linear. And I heard weak. And we can say weak if you want right now. Keep in mind, if you look at your decisions you made for the x and y axis, all right, you might think based on that there's a lot of scatter here. But there's actually not a lot of scatter in between these points. So you can put whatever you want, weak, moderate, or strong, whatever you want, Edgar. I'm going to show you later how you go back and change it, okay? So I'm going to put strong. Association between, what was the name of our x variable? Horsepower. And miles per gallon of these vehicles. Yes. Is this empty box here available for us to write? Sounds great. Absolutely. It's reserved for whatever you want it to be, which can be this sentence, if you want. I'm so sorry I did not make that clear, Leslie F. Yes, Catherine with a K.
How is it linear if it's not very straight?
You don't think it looks linear?
No.
Let's see. I think when I look at it, this point here might cause you to think that maybe it's curving up, but ultimately I do think it's having a top left to bottom right movement, then the line and the dots look pretty close. So I think it's linear. The reason I'm saying linear is if I don't say linear, I can't really look at the correlation coefficient and think that it's valid. So let's look at what R is to see if it helps us decide if it's going to be linear or not. Okay? Okay, so let's find the correlation coefficient. So hit these two little arrows to get your list back. Do you see the next box underneath your table, line 2? So click there. All right, now here's where it gets exciting. All right, I hope you're excited. Now we're going to do something that we don't need yet. I'm actually going to put on this scatter plot something called the linear regression model. Now this is something, Daisy, we're not going to need this week. But in order to get the correlation coefficient, I have to do it this way. So I'm going to show you, we're not really going to use it yet, but it's going to be pretty awesome either way. So first thing I would tell you to do is, do you see where it says the show keypad? Click that show keypad. All right, I would like to type in the equation for a line. What do you remember as the equation for a line? Excellent. So what I'm going to write is y. Where are you, y? There you go. Now, I'm not going to write equals. All right, and even before that, I'm going to back up. I'm not going to write y. Do you remember in our table what our y value was called? Do you see up in the table? I'm trying to show it with my cursor. See how it's y sub 1? Type in, it is the response, and it is MPG. Do you see next to the numbers 1, 2, 3, there's an A with a lowercase b? I want you to click that. That puts it in the subscript. And then type the number 1. So everyone should have y sub 1. Does everyone have that? Okay. Now I want you to arrow out of that. So hit the arrow to the right, and that'll get you out of the subscript. Okay, so now it's flashing normally. Now here's where we would think we would use equals. We're not going to use equals. If you go back to the ABC and click that button, do you see next to the braces and the comma, there's this little, the symbol for approximation? See that symbol? Yeah, the squiggle. You can click that. Okay, so there's that right there. Okay, everybody good? All right. Now, for mx plus b, you're going to write m and then x. But again, if you look at our table, we didn't use x. We had x subscript 1. So you want to do that subscript again and put the 1. All right. You'll notice it put a line on there. Get out of the subscript, arrow over, and hit plus b. And oh my goodness, it just made the least squares regression line. Now again, I'm not going to go into detail what that line is or how they got it, like all that stuff is next week. All right, it is called the line of best fit for those of you in apes. But the key thing I want to know from here, if you scroll down, you see where it says statistics? There's a letter there that I care about, the R. And now the first thing you should notice, the R is negative. So that confirms what we said when we wrote there is a negative. So it's confirmed. Do you see what R says? 0.869. Guys, that's strong. Anything that really gets past 0.85, I'm thinking strong. Okay? So that's why I wrote strong. So if you wrote weak, I would go change it. I would probably take moderate, moderately strong, but really this is strong. Okay?
So it's like strong.
Strong. You could write moderate. Moderate's really more like 0.4 to 0.7-ish. Closer to 0 is weak. Yeah, I mean, especially if you look, Jarvis, listen guys, once we put the line on there, Jarvis, which I'll talk more about next week, you see how they're not really scattered that far apart? So the closer those are to the line, the stronger it is. All right? We'll talk, again, a lot about that next week and the week after. Okay, so let's answer the rest of those problems. So we created the scatter plot. We wrote down a sentence. There's the correlation, so you should write in R equals, don't capitalize, please. Stop it. Cute. Negative, I think it was 0.869. Yep, 867. 8687, right? 8687, so 869. Now, what did I write wrong? I'm sorry, let me go back. 869, it's 869. Now, Saul, I told you, don't ruin this. When you look at the scatter plot, you should see that as we're moving from left to right, right here is low horsepower, high gas mileage. And as we move to the right, we have cars that have more horsepower and a lower gas mileage. So the statement I would write for the last one, right, the last statement here, would be something like the higher the horsepower I have in my engine, the lower I expect my miles per gallon to be, or lower my gas mileage to be. Now, I want to be very clear when I'm writing the sentence. Do I think that horsepower causes your gas mileage to decrease? It's not what I'm saying here. Correlation does not mean causation. I'll type it out for you, Willie J. That's why I say expect. All right. Also, is horsepower the only thing that is factored into figuring out your gas mileage? No. There's lots of other stuff that goes into it. Okay? All right, so let's stop here. You know what? I'm a rebel.